will focus on policy-related work because both the EUI's broader scope and rationale is to work on policy-relevant issues, but also because this conference also focuses on issues that are related to energy and climate policy. And I was asked to talk about energy efficiency, so I will try to provide some reflections that I have compiled very recently. Don't consider them to be final, full, or whatever, and I would welcome any comments. And these reflections are based primarily on our work that we have been doing very closely with the government of Cyprus over the last 3 or 4 years to prepare the national energy and climate plans, then to try to assess all the impacts of the Fit for 55 policy package that was proposed by the European Commission in summer 2021, and most of these proposals have become one way or another now EU legislation. So there are different aspects of energy efficiency, which is a very broad term and a very difficult to quantify term in some cases, apart from the purely technical part. So there are points for discussion or for reflections, nothing particularly authoritative on this. We know that improving energy efficiency and allowing for or enabling energy savings is considered to be essential on our way to decarbonization. We know that, for example, the International Energy Agency calls efficiency as the first fuel for a sustainable global energy system. The US Department of Energy calls energy efficiency a vital component in achieving a zero emissions energy system. And more specifically, the European Union has adopted this so-called energy efficiency first principle. It was initially included and defined in the governance regulation of 2018, Energy Union Governance Regulation, which brought together energy and climate policy in one set of plans for each member state to submit. But it was also more strongly legally adopted and established as a fundamental principle in the revised Energy Efficiency Directive that came into force last month. So it was given, this energy efficiency principle, a legal standing for the first time. Energy efficiency first, according to Article 3 of this directive, says that member states shall ensure that energy efficiency solutions are explicitly considered when planning large investments of values of more than 100 million euros overall, or 175 million euros for transport infrastructure projects. But the directive also says that even for smaller investments, the energy efficiency first principle has to be reported, to what extent the EU member states have taken into account for this. So whether they have accounted for energy efficiency before promoting additional energy supply measures, even if they are supposed to be green energy supply measures. So we know that it is considered essential. Now, by different end-use sectors and in power generation, there are different characteristics, of course, because energy efficiency, as I said, and you know very well, is a very broad term. For example, in the case of buildings, in new buildings, there are strict requirements, energy performance requirements, and you probably know that there is a revision of the energy performance of buildings directive that is under negotiation. So for new buildings, we would say that energy efficiency is taken very seriously into account. But of course, the existing building stock is primarily responsible for most energy consumption and then also emissions. And there it's energy renovations that are promoted in different countries, from simple renovations such as roof insulation or changes of windows, up to full-scale renovations of buildings to nearly zero energy buildings. We'll come back to the challenges and the barriers. In industrial sectors, again, for new industrial equipment, there are ever more stringent energy performance requirements. For the existing stock of equipment, some retrofits may be possible, or just a replacement by the end of the lifetime of equipment with new, better energy performing machinery and equipment. And in the case of road transport, For new vehicles, especially electrification, can lead to much lower energy consumption per kilometer, apart from the other issues related to emissions of electric vehicles. In the existing stock, there's not much that can be done. There is a very limited potential for retrofitting existing cars and trucks. But what perhaps one could think about an energy efficiency policy for the existing stock of vehicles is accelerated scrappage. And many countries have implemented such measures over the years. We heard also a very nice analysis on scrappage, on a scrappage scheme of Finland by Marita Laukanen in the energy efficiency session earlier today. But for each sector, there are barriers or challenges for energy efficiency improvements. In the case of buildings and industry, which means renovating buildings and improving the efficiency of industrial equipment, we have the well-known and well-documented and analyzed barriers, such as financial constraints, bounded rationality of citizens and firms, costs because of inconvenience, landlord-tenant dilemmas, and so on. Again, the energy efficiency session earlier today showed this with the presentations of Catherine Hasselt and also Patrick as well. But Patrick's presentation was about the interaction with renewables, and I'll come back to this in a while. So we know the barriers. It's good to analyze them further because we have increasingly stringent, increasingly ambitious policies, and the more ambitious the policies, the more important the barriers become to overcome. We have other problems, challenges, such as the recently increasing cost of materials for renovation of buildings, for raw materials, for machinery, for equipment, for heat pumps, and so on, which makes renovations even more difficult because more costly. There is a very serious issue around Europe with labor shortages. At the same time that there is this renovation wave at the EU, based again on European Commission's initiatives, where every country must renovate a substantial amount of its building stock, public and private buildings. Almost all member states are recording very severe shortages in labor in the construction sector. And this is a very serious issue that can really undermine the credibility of the energy efficiency in buildings targets. One particular aspect may be that energy renovations of buildings compete with the construction of new buildings. And we know this from our own policymakers in my country, but it has been very, very nicely documented in a recent report by France Stratégie, which is the strategy unit of the French Prime Minister, if I am correct, which shows that in order to enable all the building renovations that are necessary to meet the major policy targets on energy efficiency in France, almost all new construction must stop, which means that in terms of labor and in terms of profitability for construction companies, the tendency is towards new buildings, so that there is an additional challenge there to enable the energy renovations that are necessary. So this is a very brief outline of the challenges in buildings and industry. Now, in the case of road transport, since the improvement in energy efficiency can come with electrification of cars, buses, and to some extent trucks, an important barrier still is the purchase cost of electric vehicles. It will probably go down. That's what assumptions are and policy initiatives are promoting, but we are still not there. Another barrier could be the sufficient charging infrastructure for electric vehicles. In some member states, it's going better. In some member states are lagging behind. So it's also a chicken and egg problem. There is clearly a very strong push for policy in OECD countries in general, not only in the EU. For example, if one observes the International Energy Agency's Global Electric Vehicles Outlook of 2023, or the EU's scenarios of the Fit for 55 package, it is considered very likely that more than half of the sales of new vehicles by 2030 in Europe and also in North America will be battery electric. This is considered by national policymakers sometimes very ambitious, but at the same time there is such a push, such a strong push and such a focus also of automobile manufacturers, European, American and Chinese, on electrification that a very strong increase may happen. Now the issue is, however, because we are not going into a mild decarbonization path, in theory we should aim for net zero. And then we have noticed that the interest in energy efficiency in some circles, in citizens, but also in some policymakers, seems to be going down. So some people do not seem to care that much for energy efficiency compared to renewables. The thinking goes like that. If we have abundant renewable electricity, and now at quite low cost, we can have zero-emission vehicles, zero-emission buildings, and we didn't care that much about their energy performance, since we have abundant renewables. If we proceed with electrification, with abundant renewable electricity, whose costs are going down, why care that much about energy performance? We have been used to talking about the multiple benefits of energy efficiency, the side benefits of energy efficiency improvements, which are many. Well, some of them, for example, less air pollution because of less energy consumption, and then lower emissions of air pollutants and carbon dioxide if energy in the economy is based on fossil fuels, or the lower import dependency for those countries that are depending on energy imports. So lower energy needs, thanks to energy efficiency improvements, would improve the import dependency of the countries. Some of these side benefits may tend to disappear if we have ample renewable electricity at low costs. And if indeed the costs, particularly the operation costs of, for example, solar panels, are very low, and the costs are going down even for the installation, let alone for the operation, then the cost argument may not be very strong. The argument that energy efficiency improvements in vulnerable households can alleviate energy poverty may not hold that much, because if we can power all vulnerable households with solar panels, then why do we need to care that much about energy efficiency? Well, perhaps we think we know some of the answers to these questions. First of all, okay, renewable energy is renewable, is abundant, but we cannot harness it immediately. And the future energy needs, even for renewable energy, will be large, and they need infrastructure. So it doesn't happen like that. So we cannot just forget energy efficiency issues. And of course, if we power all energy wasting buildings with solar panels, okay, they may become even zero emission buildings, but if they are wasteful in energy, then this will burden the electricity grids as well, because almost no building or no industrial unit will be autonomous. There will need to be exchanges with the electricity grid, so it matters if the building stock emits X, consumes X units of energy, or 30% higher than X. It will increase the burden to the electricity grid and the additional infrastructure investments in further grids or in storage. And obviously, the more efficiency improvements we can achieve from power generating units, wind turbines, solar panels, but also electrolyzers for green hydrogen, the less extra investments we may need. And we know very well that the additional investments that are needed for the net zero transition are very substantial. So we don't want to put an additional burden and need more investments because we have energy systems that are very wasteful. So we think we know the answers, but this was also this could also be an argument that with higher energy efficiency and lower energy demand, this will help perhaps keep ETS and ETS2 prices at lower levels. Now, Okay, we think we know the answers, but at the same time, with cheap renewables, it's getting more difficult to convince many policymakers and many citizens. For example, there is a tendency to have initiatives like solar panels for all households and micro businesses, to get them to zero energy, to lower their energy costs, and so on. But if this happens before even insulating the building roofs, which may be the simplest and the most perhaps effective individual energy efficiency measure, and if you have already in your roof a solar panel and you haven't insulated your roof, then it will become even more unlikely that you will insulate your roof later, where you have to remove the panel. All energy efficiency improvements are burdensome to the building owners and so on. So let alone if one has already installed solar panels. So there is a tendency of some policymakers to improve solar panels or to improve overall renewables with storage, but before enabling some energy efficiency improvements, which are by definition more burdensome, have higher inconvenience cost. At the same time, this discussion about green hydrogen is a big discussion. And we know that, okay, we will certainly need green hydrogen, I mean renewable hydrogen, hydrogen produced through renewable electricity for a net zero system. But we know that these processes are very energy inefficient. So this means that we need much renewable electricity to produce green hydrogen, and at the same time we need this renewable electricity for all the rest of the needs of the energy system. So I believe that we need to emphasize very clearly that we will need green hydrogen very focused on the very hard to abate sectors that cannot get to net zero with electrification. For example, aviation and shipping. Again, we will probably not have hydrogen, but hydrogen-based fuels that can power ships or airplanes, hopefully in the future, and also high-temperature industry. But there are many discussions, to promote green hydrogen as an energy storage medium, or even for power generation. But imagine to spend renewable electricity to produce green hydrogen, which you will store, and then burn again to produce electricity again. This is very energy inefficient. So this may be quite obvious to us, but for policymakers or also for some entrepreneurs that like to promote their investments, these are things that have to be considered and perhaps emphasized. And these are points where energy efficiency issues are important. And as regards hydrogen, I like this quote from Kurt van den Berg, the Director General of DG Klima of the European Commission. In a public discussion in September, he said that one thing that keeps me awake at night is that we don't have a solution for the energy-intensive industries in Europe. Again, this relates to green hydrogen. I mean, we need huge amounts of green hydrogen if we are going to fully decarbonize aviation, shipping, and heavy industry. So again, this points to the issue of energy efficiency being important still, even though we may have many renewable options of low cost. But we must illustrate these potential benefits of energy efficiency as clearly as possible and in an as quantitative manner as possible. That's just an example. We prepared a net zero transition study for our country, for Cyprus. And we have the main net zero scenario for which the total electricity demand evolves according to this gray curve, which means that under net zero conditions, we need double the electricity that we consume today. And I think that's Europe-wide the same. And we tried to illustrate how much more electricity we would need if energy efficiency does not improve fast, or if energy efficiency is stagnant. Okay, the blue curve may be unrealistic, it may be too pessimistic, but the red curve is not pessimistic. We say here a net zero scenario with constant or with not improving energy intensity, and you know that energy intensity is much broader than energy efficiency, but since the other factors that affect energy intensity do not change according to these scenarios, any change in energy intensity here has to be attributed to lower or higher energy efficiency. So we calculated, for example, that the already high electricity needs to get to net zero would have to increase by 20 to 100% if we do not improve our energy efficiency. And this translates, of course, to investments, to additional investments of 2 to 7 billion euros, which may sound little for European standards, but for a small country like Cyprus, this is substantial. This is just an example that we have to illustrate the importance of energy efficiency to policymakers and to citizens and business associations which put pressure to policymakers as clearly as possible. Now, of course, we have been used to saying that energy efficiency measures are, the cheapest decarbonization option. We know the marginal abatement cost curves, which show that for many energy efficiency improvements, the discounted costs are even negative. Okay, in real world, okay, it may not be that simple. If one has mild decarbonization targets, so not net zero, but 50, 60, 70% reduction, then we know from the studies and from our calculations that we could have very low or even negative discounted lifetime costs of energy efficiency improvements, so these are cost effective. In reality, things become a bit more complicated. Taking into account all the real life constraints, as you know, financial burdens, lack of access to capital, administrative capacity if one thinks about subsidies for energy efficiency improvements, rebound effects, and also the other barriers to energy efficiency that we have mentioned, the abatement costs may be higher than that. For example, if we take real life data from the subsidies to energy efficiency improvements in private households, vulnerable households, and public authorities of the recent years in Cyprus and analyzing them, we find that, okay, the costs of a real world investment are not that low and probably not negative because they may not be the most low-hanging fruits, but they of course, they are not very expensive. But we need to take into account the real life constraints in any case. Now, if we are, however, going towards net zero emissions, the energy system and the total economy have a bit different requirements because net zero is not a business as usual pathway. So if policymakers ask for the least cost solutions, we know that today's least cost solutions may not be the ones that will lead us to net zero. So they may lead to investments that will lock economies or sectors in a higher carbon emissions path. And therefore, then if we have to immediately switch to net zero, they can lead to stranded assets. The most cost-effective policies that are required to reach an intermediate target, for example, the 2030 EU target or the 2040 decarbonization target, which will be proposed by the European Commission next year, may not help achieve the longer-term net zero target. So we need to keep this into account because we also have, perhaps it goes without saying for us and for our analysis, because we solve our models with backward induction and so on. But this has to be made clear to policymakers because otherwise policymakers instinctively ask for the least cost solutions and ask for cost effectiveness. But how is cost effectiveness determined, or how is cost benefit assessment determined? So we need to make them understand about the dynamic efficiency issues and with a strong, ambitious target of 2050. So energy efficiency measures must be prioritized, but based on the contribution to the net zero target, not just any cost-effective energy efficiency measure to be prioritized. But we must consider the real-world barriers, and we should not make, I think, overly optimistic assessments. We may have this trend because that's what our models show, with very little friction, with very little anomalies, with very little market imperfections or whatever. It's not easy. The shortages of labor, the costs of raw materials, the administrative weaknesses in all administrations, in all countries, The issues of reluctance of citizens and firms, especially for the not so obvious energy efficiency investments, may increase the costs. So these are things that we have to understand better and then communicate to policymakers better. And I think an additional assistance to this could be to try to apply behavioral insights to overcome barriers with the aid of behavioral scientists and economists. So I will conclude with some reflections based on energy efficiency on the issue of science-policy interaction. I think energy efficiency is a good example where things are quite complicated, and understanding the issues, communicating them to business associations, to policymakers, and to the public has additional requirements. So we're talking about science with policy. You probably know that the European climate law has established a scientific advisory body on climate change at EU level, which is hosted by the European Environment Agency. But at the same time, the law says that each member state is invited to establish a national climate advisory body responsible for providing expert scientific advice on climate policy. Many member states have such a body, some member states don't. Of course, there is a large variation in what these bodies can say. So there is a clear push at European level, and not only at European level, but also from other international organizations, to promote the science policy interface. I think that policymakers need scientific support more than ever, especially for the transition to net zero, because net zero is an unconventional way. And I don't think that there is any other policy that is similar to net zero. I'll come back to this at the very end of the slide. And in this respect, energy efficiency is a key topic, that we need solutions beyond textbook recommendations. Herman Follenberg said yesterday, economists must get better at policy recommendations. They are better than some other social scientists think, but they need to get better. And energy efficiency is a quite complicated issue. Of course, not the only one, but I was asked to talk about energy efficiency. That's why I highlight this. Now, in this discussion, in this intercourse between scientists and policymakers, I would say that the successful engagement of researchers with policymakers is as much about content as about the process of the engagement, which means that building trust, providing, having good interactions, providing realistic ideas, recommendations, opinions to policymakers is important, because this helps build trust, and it makes it more difficult for policymakers to dismiss some scientific advice as purely theoretical or impractical or unrealistic. And since we are in Machiavelli's town, we can paraphrase a bit Machiavelli, that it's both who said something like, we need good laws and good people. So it's both institutions, but also persons that matter in this engagement between science and policy. It doesn't take more than one or two policymakers to trivialize any scientific support, and it doesn't take more than one or two scientific advisors to say something irrelevant and then help policymakers fully dismiss scientific advice. So it requires a balanced approach, I would say. So this highlights the need for realistic simulations for energy efficiency measures and many others on the road to net zero. We need to understand the synergies. We need to understand and highlight the trade-offs, because there are also trade-offs. There are not only win-win solutions, as we know. So deep decarbonization is not easy. We need to illustrate to policymakers that net zero is something special. Do you think, can you imagine of any other policy in the public policy domain that has a target similar to net zero, something that is long-term, that is ambitious, that is economy-wide, but it has also a very concrete number? Well, almost. It's not zero, it's net zero, so it's not a fully concrete number. But I don't think there is any other example of public policy where there needs to be a target, a holistic and ambitious target with a specific number so far in the future. So this is a major challenge. It's a challenge for us intellectually, but it is, I think, part of our duty to our societies to help address this. Thank you very much.